Welcome everyone, I'm starting to do some tutorials here. Feel free to let me know if this structure is helpful to you. Today we're taking a look at the new regular Astrominx by MF8. It's closely related to the 9th Megaminx ball, Curvy Starminx, and Starminx. Many of the techniques from this puzzle can be translated to those puzzles, and vice versa. I'm sure there are several ways to approach this solve, but here's an overview of one good way to do it. Start by solving these edge pieces. There's an easy way to do this, but it scrambles the other pieces, so it's best to do the edges first. You can use the corners as guides for which colors go where. This is mostly intuitive, but there is a trick to help finish off the last layer of edges. The next thing to do is place these corner pieces relative to the edge pieces without worrying about how they're rotated. There's an easy cycle to move the corners around. It does affect some of the petal pieces though, so it's important to solve the corners before the petals. After that, rotate the corners into place. There's an algorithm to rotate a single corner without changing any of the other pieces. After rotating the corners, the last thing to do is to place the petal pieces. Technically, this can be done before or after rotating the corners, but I like to have the additional context from the corners already in place to see where the petals go. There's a nice 3-cycle to use here too. On many puzzles, it's helpful to start at one end and solve working toward the other side, building up the solution gradually. For this one, it's easy to do that during the first step when you're solving the edge pieces. For the steps after that, I prefer to just pick up whatever pieces are convenient instead of starting at one end and finishing at the other. For tutorials, I find most of the time it's easier for me to visualize algorithms on a solved puzzle. So I'm going to show all but the first stage on a solved puzzle. That way I place the edge pieces, the way I place the edge pieces makes an absolute mess of the other pieces. So I'll show that stage on the scrambled puzzle. Let's start that step now. The basic way to move these edge pieces around is to center on a corner and then do up, up, down, down like this. So up, up, down, down. This moves these 3 edge pieces around with a whole bunch of other side effects that we don't care about at this point. If you start on the left, it takes the bottom left to the top piece to the bottom right, and the bottom right to the bottom left. If you start on the right, it does the reverse of that. Sometimes when you place an edge this way, it may end up flipped from how you want it. While you have unsolved space to work with on the puzzle, you can flip a single edge by rotating it partially around an unsolved corner and then putting it back differently. Depending on how much space you have left, there are different ways to go about this. So say you want to flip this piece. If you don't care about rotating this corner, so all of these pieces around with that rotation, an easy way to flip it is to use the 3-cycle to move it here, and then rotate this corner to put it back where you want it. Here's what this looks like. So up, up, down, down, and then rotate it back. And now this is flipped. If you care about keeping the other pieces affected by this turn in place, this turn in place, but you don't care about messing with just this inner ring of edges, you can use the commutator to move the piece you want to flip. So from here to here, and then from here to here, and then from here to here. And here's what this looks like. So there you go. Now for the least invasive version of flipping edges, if you want to flip, we'll do these two. If you want to flip these 2 pieces without affecting any of the other edges, you can do the same thing, but finish with an additional 3-cycle to put everything else back. So what I do is I remember this piece goes to the left of the 2 that we want to flip. So then I'll take this one and do the same thing as before. So go from here to here, here to here, and then here back to here. And then we'll put this one back in place. And here's what this looks like. So up, up, down, down, up, up, down, down, up, up, down. And then I think it was is this one that we want to go to put back there. Up, down, down. There we go. So yeah, now we flip these two, and these are the same. So now let's talk about how the gradual building process works. To start out, you pick a corner piece to use as a guide and then assemble the ring of edge pieces that will eventually go around it. For now, it doesn't matter if the corner is actually in the center of that ring, just that the colors are lined up correctly. And from there, you can expand outward to cover the rest of the puzzle, finishing at the ring of edges opposite the one that you start with. For the first two rings, it's often fairly easy to just position the edge that you want intuitively without actually using the 3-cycle. I'll go ahead and place the first ring now. Okay, so here's the first ring of edges, and then I used this corner as a guide. So you can see these are the colors of the faces, and they correspond to these, the way I've placed these edges. So once the first ring of edges is placed, you can move on to doing the next ring of edges by putting in the remaining edge for each of these faces. And I'll just go ahead and do that now. Okay, so one thing I did forget that might also be helpful is that if you want to flip an edge when you have so much space left on the puzzle, it can be helpful to just, instead of say we want to flip this one, instead of using the 3-cycle to move it from here to here and then rotating it around, or here to here and rotating it around, you can actually just move it and then turn it like that. And when you're working with a lot of space left on the puzzle, simpler solutions like that are open to you. Okay, so I've done the next ring. So as you can see, the edges for each of these faces are done. At this point, you usually want to think or start thinking in terms of using the 3-cycle, possibly with some setup moves to move things around. The corner where the last ring of edges will go is still free to move around, as is, for now, this center band of pieces if you need to use either of those. And although this is what we're going to be building next, so not for long. Anyway, so you can use this unsolved corner that can rotate to flip edges as needed. For this next ring of edges around the middle of the puzzle, you'll want to check against one of the corners that will eventually be in one of these spots next to the ring of edges that you started with. It will tell you which edge goes on which side of one of the next ring of faces. So if you'll look, all of the next faces that we're looking at have 2 edges that need to be placed, and you just need to know which one goes on which side next. And once you have one edge in this layer placed, you can work your way around the rest without needing to consult the corners again, since the edges you've already placed will show you what's left that needs to be done. So to place pieces in this middle layer, you can cycle 2 pieces from the second to the last layer along with 1 from the middle layer. So for example, all right, here's the middle layer of edges, second to the last layer, last layer. And so like I could use the 3-cycle on these with this one. So we have last layer, second to last layer, middle layer. You can also do 2 with the last layer like this. If you're on this side, you can do the middle layer, second to last layer like that. You've got some options. So while working on this middle layer, it may end up being convenient to exchange pieces between the last layer and second to the last layer. This is usually more useful at the end when you're finishing off this layer, but you may need to do it for like flipping pieces and stuff, just depending on what you find convenient. So you can do this though by just, so say we're interested in this one, you can just rotate it up to the last layer. So now this one's on the last layer of edges here. These 2 we don't want to mess with, but you can exchange it with these 2. So if I want this one on the last layer, I'll just do the 3-cycle with these. And then move this back down. And so now this one's on this last layer of edges, and we can do whatever flipping or whatever else needs to happen with that up here, and then move it back down. So I'll go ahead and solve the middle ring of edges now. Okay, so I've done the middle ring. So here's the first ring, here's the second ring, here's the middle ring, all the way around. Again, you have to verify against one of the corners when you're starting that one. And then once that's done, you can solve this second to the last layer of edges. To do this layer, you'll want to start using setup moves or to exchange pieces between the last ring of pieces and the current edges, or in the current ring of edges that you're working on. Like I showed a moment ago. If you need to flip an edge, you can just put it in the last ring and then flip it using 3 cycles without worrying about about the other pieces in the last ring of edges. So I'll go ahead and solve this second to last layer now. Okay, so again, one more helpful thing that I forgot to mention earlier that could be useful to you is sometimes a different kind of setup move to be able to get up to between this layer and this layer is to actually, so this is the last ring, and this is the second to last ring. You can actually take these and move them like this, and so these 3 are from the last ring, this one's from the middle ring. Anyway, so I went ahead and, or not middle ring, second to last ring. Anyway, I went ahead and solved this second to the last ring. So that's done. Now you're ready to tackle the last layer. So you just want to start by using the 3 cycle to put the edges in place, regardless of whether or not they're flipped. If you end up in a situation where only 2 edges are swapped, that indicates that something is wrong with the color layout. This can happen if you made a mistake when checking against the corners earlier on in the solve, and you'll need to back up and fix that. So if you end up wanting to do a cycle of edges that are all next to each other, you can use setup moves to make that work. For example, if I want to cycle these 3, I can turn this one over to here and then back to here like this. So now I'm looking at these 3. Then you do the 3 cycle algorithm and undo those 2 moves, the 2 setup moves. All right, now I'm going to solve this last layer of edges. All right, slight issue with the time lapse there, but this last layer is done. And I happened to be fortunate and end up with all of these already in place, so I didn't need to use the edge flipping algorithm to finish off. So if you need to, though, you can finish off using that edge flipping algorithm that I showed earlier. And if you end up coming across the case that you have 2 that are separated and not next to each other, then what you can do is say I want to flip these 2. I can put them next to each other just with a single setup move like this. Now they're next to each other. Great. So yeah, once you've put all of these edges in place, then you can use the flipping algorithm to make sure that they are all oriented correctly. So that's how you do the edges. Now I'm going to just jump forward to showing the remaining algorithms on the solved puzzle, since it'll hopefully be easier to see what's going on there. From here on, I didn't find building the solution gradually from one end to the other to help much. It's a lot easier to just pick up whatever pieces are convenient when you're just looking for things to, whatever fits where. So I'll go ahead and do that. Okay, here's the solved puzzle. To move the corners into place, we're going to extend the idea of up, up, down, down to include groups of moves. A move sequence formed in this way is called a commutator. The key idea is to do something, then do something else, then undo the first thing, then undo the second thing. You want to pick things that only overlap on pieces that you want to move around. In this case, the key overlap is the corner. The corner in this position. To start out, I'm going to do up, up, down, down, starting with the left is my convention, but it doesn't actually matter. Like this, so up, up, down, down. And then that's the first group of moves. This moves a corner from here to here, and then I'll rotate either like this or like this. So we'll do this one. And that moves, and then that's the second thing. So this moves a different corner into this position. And then after that, I'll do up, up, down, down, starting on the right. Up, up, down, down. To undo the first operation, and then I'll undo the second move. And as you can see, there we go. This only affects corners and then also petal pieces. And so when solving this, I do this step before solving the petals, so it effectively only changes the corners. In this algorithm, this back turn it can go however far in either direction you want, and it can be on either side like this. This corner, so when we're centered on this one, we move it from here to here with the 3 cycle, and then this corner goes into whatever, or the corner that is here goes into whatever space you move there using the back move. And then the corner that was in the space back here comes down up front. You can also start by rotating one of these back layers and then doing the up, up, down, down afterward instead. And then you just, undo the back rotation and then undo the up, up, down, down. And this does the exact same thing, but it cycles the corners in reverse of the order I just talked you through. Okay, so like I said earlier, I don't usually place the corners in any particular order or pattern. When arranging the corners, I also don't worry about how they're turned as long as they're placed inside the correct group of edges. So once all the corners are placed correctly, then I use this next algorithm to rotate the corners into place. Let's take a look at how to do that. So if you look at what pieces move, so you have all these, what pieces move when you make a turn, you can rotate a single corner by rotating all of these other pieces in a turn and then doing the turn to put everything other than the central corner back into its place. The way I do that looks at these 5 groups of pieces centered around the central corner. And they look kind of like flower petals. There's that, there's this one. For example, if I move each group 1 clockwise and then do a turn 1 counterclockwise, the result will be this corner being rotated once counterclockwise and then everything else remaining the same. On the Twisty Puzzle forums, there's actually a name for this idea. It's called a residual twist. That's the core idea of this algorithm. You take out one of these petal groups and then put it back rotated to where you want it, and then put in the one that you just displaced, then put in the one displaced by that one, etc., until you've rotated all 5 groups, and then that just leaves the corner. And then you can just do the turn at the end to put everything back except the corner, which will be rotated. It feels a lot like if you were going to rotate the corners of a face on a Megaminx, so maybe that's something that you might be familiar with. But instead of dealing with corners, you're doing these whole blocks of pieces. When you're done moving the blocks around, you can do a normal turn to get a single rotated corner instead. So here's what that looks like. All right, so I go down, over 2 with the bottom, bring it back up, over, down, back, up, rotate the top, bring it down, over, up, back, down, over, up, back, down. All right, so we've rotated these groups, and then we do the turn, and there's the rotated corner. So you may have picked up on that I don't actually have to move this layer 1 step counterclockwise each time like I just did. So say, for example, I want to rotate the corner 2 clockwise instead. I can rotate the top 2 clockwise at each step where I rotate the top instead. And this inserts each group of pieces 2 counterclockwise from where it was, and then you finish off by turning 2 clockwise so that the corner is turned 2 clockwise. This one can be a bit tricky to visualize, so if you're having trouble with any of these, I'm putting links in the description that let you watch the algorithms in a simulator. And then also something that helps too when you're lining things up, you didn't get to see this the first time through the algorithm, but you can actually check that you're bringing in the right group of pieces when you're doing this bottom turn, because sometimes it's easy to forget whether you're supposed to be turning this way or this way to bring back in the pieces that you want to line up next. But you can actually check the edge that's in this position versus the corner here, because when you have this down here, you'll be able to line the edge up with the corner. So watch for that. I'm going to actually put this corner and rotate it back where it was. So I'm just going to essentially undo what I just did with the algorithm. So I'm just going to turn one clockwise on the top instead of one counterclockwise. So that'll rotate this corner one clockwise, and we'll go through that. So 1, move it over 2, back up 1 clockwise, down, bring it back. Notice that this edge matches this corner. Bring it back up 1 clockwise, and then I'm going to keep going. And this way you can check that you did the correct rotation here with the thick bottom layer. Yep. So there I made a mistake and went the wrong way, but I just went overshot and just went one more to get the correct edge lined up. So that helps if you're prone to making mistakes like that. All right. So I mentioned in the mini review that the corner caps tend to fall off. It's annoying, but the fact that there's an algorithm for twisting a single corner is why this isn't as much of a big deal. As long as it's only one cap that falls off, you can just put it back where it was. If you've already done this stage and rotated the corners, then you just put the corner back in the correct position. And if not, it really doesn't matter how it's rotated when you put it back in, because you're just going to do this algorithm anyway. On the off chance you like drop it or something and you have more than one corner cap come off all at once, you can still just put them back. And if you've already put the corners in the right places, you just put it in the right place, or put them all in the right places. And if you haven't solved them yet, then you just put them back and solve them. And if you're so unfortunate as to have multiple of them fall out, you may end up, after solving, with 2 corners swapped. That's not a reachable state with normal moves for this puzzle, so you just have to pop the 2 corners out and swap them, and then you move on. All right, so now that you've rotated the corners, the only remaining step is to fix the pedal pieces. As I mentioned earlier, there's not an easy gradual way to do this. I just jump around wherever on the puzzle and pick up whichever pieces are convenient. That tends to minimize the setup moves more than building things gradually does. There are 60 pedal pieces on this puzzle, so there are usually some easy ways to solve things with relatively few setup moves. Usually it's not hard to find a way to cycle 3 pieces that puts at least 1 or 2 of them into the right position. Only at the very end do the setup moves get a bit more complicated. So here's how to do the 3 cycle of the, here's how the 3 cycle of the pedal pieces works. It's yet another example of generalizing the idea of up, up, down, down to include groups of moves. So again, the idea of that is the commutator. Notice that if I do up to, so I'm gonna we'll face this blue face. I'll do up to, down to, down to, with 2 faces, 2 faces separated like this, or 2 corners separated like this. So I get this pattern where I've moved this block of pieces, this block of pieces, and this block of pieces, and everything else is the same. This is great because it overlaps with this center band of pieces at exactly 1 piece right here. The deeper cut turns actually make it so that rotating the middle of the puzzle carries fewer pieces, and so we can just move this over and then undo this. So like this, up, down, down, and then we undo the second thing, bring it back. Great. So what this does is this takes this piece, or the piece that was here, moves it here, the piece that was here, moves it here, the piece that was here, moves it down here. So yeah, anyway, the idea is to do that cycle of the big blocks, move the center band, undo the cycle of blocks, and move the center band back. Okay, and so the cool thing about moving the center band is that you can actually move whichever piece you want to have line up into this position. So like if I wanted to include this one in the cycle instead of this one, I could go like this instead when I'm doing that first move to bring something else in place here. So you can actually have any 2 pieces of this center band participating in this 3 cycle. And then on top of that, you can also cycle the blocks in the opposite direction. So you could Here, I'll undo what I just did and then show you what I mean. So here's what I'm undoing. So you can, in order to reverse this, you can start by rotating the center and then do the up, up, down, down with the blocks like this. Back, and then it's the right, yeah. Great. Okay, so the other thing is that I can actually start on the right if I want to with the block cycle. And so instead of, if I don't want this piece, if instead I want this one over here, which points the opposite direction, and it's just positioned differently, but yeah, it points the opposite direction, then I can start on the right and do up, up, down, down, move the center block. And again, I can move this however far to whichever one on the center band I want to include, and then undo the blocks again. Great. Okay. So one really easy setup move to use with this 3-cycle is to just rotate this bottom layer and to position different pieces to the back. So if instead of this one I wanted to include this one, I can just turn the bottom once before I do the algorithm and then move it back. And so given that you can cycle the blocks in either direction, and then also rotate the middle however you want it to, this commutator just generally lets you do the 3-cycle with one pedal that's just below this cut facing either direction, and then 2 pedals that are in this middle facing up, well, or down, however you want to say it. Anyway, so any of them that are directly below a corner like this, so right here. So you get to pick any 2 of these and then one that is immediately below this cut right here. And until you get to the very end, you can often pick up many of the pedal pieces with just that single setup move. As you get to the end, it's helpful to remember that if you can line a 3-cycle up to include 2 pieces of the same color, you can handle cases that appear to just have had 2 pieces swapped. So in particular, you can pick up pieces you've already solved and swap a piece of the same color into that same position. And doing this is a great way to avoid complicated setup moves towards the end. Usually only around 3 moves are needed to set things up. I haven't figured out a really principled way to do that. It's usually pretty ad hoc, but again, you don't need that many moves to set things up to use this 3-cycle even when finishing off the puzzle. So this part of the solve is a bit long just because there are a lot of pieces to move around, but there's really not much to it beyond that. Okay, so remember to be patient with yourself when learning to solve a complex puzzle like this. Making mistakes is a normal thing, especially during your first time through. This method is the simplest I've been able to figure out, but the method I've shown for solving the edges makes an absolute mess of everything else that's around the edges that you're working on. So if you make a mistake in one of the later stages, it's pretty normal to have to clean up quite a bit. If when cleaning things up you run into a situation where you do want to just permute edges, here's a way to do that. You can do up, up, down, down with center slices, and then take the commutator of that with a rotation that only intersects with a single piece. So here's what this looks like. I'll pay attention to this position. So I'll do up, up, down, down. And then if we look at this top turn here, this is the only piece affected. So I'll swap this way, I guess. And then I'll just undo the up, up, down, down. So I started on the left earlier. I'm going to go on the right now. Up, up, down, down, and rotate it back. So in this case, I moved this one. Let's see, this one moved up to here. This one moved to here. This one moved to here. And as you can guess, you can turn this one however many spaces you want with that. And yeah. So hopefully that'll make cleanup maybe a little easier if you prefer to use this when cleaning up at any point. So, all right, that's my tutorial for solving the regular Astrominx. It's been a very fun puzzle. Thanks for watching, and good luck to everyone with solving this. Thank you.